Good morning. I am Professor Sheetal Bhujade and today I will be delivering a lecture on basics of analog communication. Now, what is communication? Communication basically refers to the sending, processing and receiving of information by electronic means. Now, communication became possible due to the invention of triode tube. It became more widely used and refined due to the invention of transistors, integrated circuits and semiconductor devices. More recently, the use of fiber optics satellites had made communication more refined, with more and more emphasis being put on data communication and computer networks. Now, a modern communication system basically deals with the processing, sometimes storage and finally interpretation of the data that has been received. So, there are three steps in a modern communication system: sending of my data, then processing of my data through the communication channel and finally the receiving of the data. Now, let us talk about the basic block diagram of a communication system. What are the different steps that my signal has to go through when it is being transferred from one place to another? So, let us talk about the block diagram of a basic communication system. Now, when we have to transmit the information, my information could be anything. I have my information signal and my information signal that has to be transmitted, it could be sound, it could be a picture or it could be a signal coming from the computer data. Now, these are the different varieties of information that you need to transmit, whether it is a sound signal, that could be a music or a speech, or it could be a data which is coming from a video signal, or it could be a data from the computer network. Whatever information can be in any of these forms, firstly your information has to be given to an input transducer. Now, what is the work of the input transducer? My input transducer will first convert your data into an electrical form. So, no matter what my information is, it has to be first converted into an electrical signal so as to make it suitable for further transmission. So, the input transducers that are basically used in a communication system, it could be a microphone, it could be a TV camera or any other thing. So, that is the first job that is done by the input transmitter, that is converting your information into the electrical form. Now, after your signal is converted into an electrical form, even then it is not suitable for immediate transmission. Lot of work has to be done on the signal so as to make it suitable for further propagation. That work lies with the second block that we call it as the transmitter. Now, what is the work of the transmitter? Now, your transmitter would be including various devices, such as it could be including a mixer, it will be having an amplifier, it would be having an oscillator. Now, what is the work of the transmitter? The signal that is coming to the transmitter is your signal in electrical form. Now, after taking this electrical signal, lot of work will be done by the transmitter, that is, it has to take care of the frequency range, it has to compress the amplitude range, and doing this work it will make your signal go through a process what we call it as modulation. So, modulation is the basic concept or the basic work that is being done by the transmitter. After your signal is being modulated, which we will be discussing later about modulation, when your signal is converted into electrical form, it will be given to the transmitter. My transmitter will modulate my signal and then it will be given or passed through a communication channel. Now, when we talk about the communication channel, my communication channel, it could be of two types. One that we call it as wired communication and the second one which we call it as wireless. When I talk about wire communication channel, we also call it as line communication channel, and second one we call it as wireless or also known as radio communication channel. Let's talk about the first one. If I say that my communication channel is a wired or a line communication channel, that means there is a physical connection between the transmitter and the receiver. If we talk about wire communication channel, we have examples like telephone system, then cable TV, all these are wired communication channel. Next category is your wireless or radio communication, wherein there will be no physical connection between the transmitter and the receiver and the signal will be propagated in the form of electromagnetic waves. So, after doing modulation by the transmitter, the signal will be given to the transmitting antenna. The transmitting antenna will radiate my signal in the free space in the form of electromagnetic waves. These electromagnetic waves will then be captured by the receiving antenna, and then in this way my signal will be propagated further. So, these are the two different types of communication channels which we have, wire as well as wireless. When we are dealing with radio communication, so mostly we will be talking about the wireless communication channel. Okay. After your signal is passing through the communication channel, one more factor which plays a very important role over here is the noise. Noise will randomly interfere with your signal while it is being propagated from the transmitter to the receiver. We cannot eliminate noise completely, but obviously we have methods to make this effect of noise as low as possible. Now, it is not necessary that my signal noise will interfere with my signal here in the communication channel. Your noise could be present everywhere. It could be present in the information source itself. It could be there while your signal is being transmitted from the transmitter and so on. But mostly the effect of noise will be more in the communication channel. As my signal, so our main effort over here would be eliminate or reduce the effect of noise as less as possible. After your signal is propagated through the communication channel, the next block that we have is a receiver. Now, what is the work of the receiver? Receiver will do the exact process of what the transmitter has done. My transmitter has modulated the signal, or we can say the process of modulation has taken place in the transmitter. My receiver will do the exact process over here, that is, it will demodulate. Whatever information we have superimposed on the carrier in the transmitter in the process of modulation, my receiver will recover that information from the carrier and it will be then given to the output transducer. We have different varieties of the receivers available. Now, the type of receiver to be used, it depends on various factors like the type, frequency of operation, then the bandwidth, then the output devices to which your signal has to be fed. On these parameters, we mostly decide what type of receiver are to be used. But the most common type of receiver that is used, we call it as Superheterodyne Receiver. Okay. So, my receiver has demodulated the signal and it has recovered back its original information. After the receiver has performed this task, the signal will then be given to the next block that we call it as output transducer. Now, what will be the output transducer doing? It will be converting my original information which was in electrical form, it will be converting it back into the original form which was either the sound, picture or the data. So, this work will be done by my output transducer and finally, my data will be fed back to the devices. Your device here at the output of a transducer, it could be a TV camera, it could be a loudspeaker or it could be any output device that is the radar display to which your information has to be transmitted. So, this is the basic block diagram of a communication system. That means when I have to transmit an information signal, be it sound or be it picture or whether it is a data, my signal will have to go through all these steps so as to be recovered efficiently by the receiver and fed back to the devices. So, this is how my signal will be propagated through the communication channel. Okay. The next point that we will be talking about is the work of the transmitter. Now, what is the transmitter doing? We will be concentrating more on this particular point here. As I have already said, the transmitter is going to go with the process of modulation. Now, what is this modulation and the need of modulation? That is a very important point of discussion and that is what we are going to see now. As I have told you, my transmitter is going to go through the process of modulation. Now, why we are modulating and what is the need, that is our next point of discussion. So, now first let us discuss about what do we mean by modulation. Well, in its basic sense, modulation is the process in which some characteristics of an high frequency sine wave is varied in accordance with the instantaneous value of information signal. So, that means if my signal is propagating, I will be superimposing my signal on a carrier and then my signal will be transmitting, and this superimposition of information on the carrier is called as modulation. Now, what is the need of modulation? Why do we modulate the signal and then transmit? There are 4 to 5 basic reasons why the process of modulation has to take place in the transmitter. The main basic reason first let us discuss is reduction in the height of antenna. Now let us talk about this height of antenna. What is the requirement? For efficient transmission and reception of signal, it is required that the antenna used should have a vertical height of quarter wavelength of the frequency used. That means h should be equal to lambda by 4, where lambda is equal to c by f. That means if I have to transmit my signal, I have to take care what is the height of the antenna, and as you could see, my height of antenna is related to what is the frequency of the signal that you are transmitting. For example, if I have taken a signal and the frequency of my signal that I want to transmit is, say, supposing 10 kilohertz. So the signal that I am transmitting is of the frequency range 10 kilohertz. So based on this, I have to see what will be the height of my antenna that I have to use at the transmitter. As per the formula, I will be first calculating the value of my lambda, which will be equal to 3 into 10 to the power 8, that is the velocity constant, divided by the frequency of my signal, and it comes out to be around 30,000 meters. Based on this, I will be now calculating the height of my antenna, which will be equal to 30,000 meters divided by 4, which comes out to be 7,500 meters, that is equal to 7.5 kilometers. As you could see, when I have to transmit a signal of, say, 10 kilohertz, the height of the antenna that I require is 7.5 kilometer, which is not practically feasible to install. That means we could reach a conclusion that when I transmit a low frequency signal, my height of the antenna increases drastically. Let's take another example now. Supposing I have a signal and the frequency of my signal is, say, 1 megahertz. Now I have increased the frequency of my signal. When I have increased the frequency of my signal, my lambda, I will be again calculating the lambda, which is equal to 3 into 10 to the power 8 by 1 into 10 to the power 6. So my lambda comes out to be around 300 meters. Based on that, I will be now calculating the height of my antenna, which will be equal to 300 by 4, which is equal to 75 meters. As you could see now, when I have transmitted a low signal, my height of the antenna comes out to be in kilometers, whereas if I increase the frequency of my signal, my height of antenna decreases. Making an antenna of 75 meter is practically feasible, and that's why this is one reason why we go for modulation. So that's why we never transmit a low frequency signal, rather we increase the frequency of the signal in the range of megahertz so that my height of the antenna also reduces. This is one main reason why we go through the process of modulation, and that is reduction in the height of antenna. Okay, so this is the first point. Let's concentrate on the second point. Second point is basically we do modulation in order to avoid mixing of signals. Now, what is this? We know we are transmitting audio signals, and the audio signals are concentrated in the audio range from 20 hertz to 20 kilohertz. Now, if I have more than one transmitter and both of them are transmitting the same signal, then it may happen that both the signals will mix together while communicating through the channel, and my information signal will be lost. In order to avoid this, what we do is we do modulation. That is, we take different carrier frequencies, and with the help of these different carrier frequencies, we are transmitting the signal, and that is possible only because of modulation. So this is the second point, that modulation helps us in avoiding mixing of the signals if the frequency of the signals is same. So that is the second reason. Third is it increases the range of communication. Now, as you could see, if my signal is a low frequency signal, it cannot propagate very far. So what we have done is, in the process of modulation, we have taken a carrier whose frequency is high in the range of megahertz. Since the frequency of my signal is larger, I can increase the range of communication. That is, my signal can propagate longer distance, and again this is possible only because of the process of modulation. Fourth reason why we go for modulation is multiplexing is possible. So let's discuss about what do we mean by multiplexing. Multiplexing is basically the process of simultaneous transmission of more than one signal over the communication channel. So again, we can simultaneously transmit signals over the communication channel only because we have modulated our signal. So that is a fourth reason multiplexing is possible. And finally, one is improves the quality of reception. Since the signal is of high frequency, my signal noise interference with my signal would be less and my signal will propagate longer distance, which will help me improve the quality of reception. So these are the main reasons why we go through the process of modulation. One being the reduction in the height of antenna, second avoiding the mixings of signals, third increase the range of communication, fourth making the process of multiplexing possible, and finally improve the quality of reception without any noise and interference. We will again revise the definition of modulation. As I have said, modulation is the process in which the characteristics of an high frequency carrier wave is varied in accordance with the information signal.